Given question, find the deflection at the free end of the cantilever. Take E is equal to 10 giganewton per meter square and I is equal to 66.6 into 10 raised to minus 6 meter raised to 4. To find out the deflection at free end by using double integration method, we will first draw the free body diagram. If we observe this cantilever, it is carrying uniformly distributed load over a span of 1.25 meter and at the free end B, it carries the point load. We will first consider any section XX at a distance x from the fixed end A. So here is the fixed end A and we will consider the distance small x. And at this distance we will consider the section XX. Now if we observe in between the point A and point C, there is uniformly distributed load. So here is the point C. Now how to show the load in between the section XX and C? So this section carries uniformly distributed load and it is given 2 kilonewton for 1 meter. So I will write here 2 kilonewton for a span of 1 meter. But in between the section XX and the point C, what is the span? So it is 1.25 minus x. Now for this 1.25 minus x distance, what is the load? So here is the question mark. So we will cross multiply this, that is 2 multiplied by 1.25 minus x, and the point of application of the load is the center point. So I will show here the center point in between the section XX and C, and the total load is 2 in the bracket 1.25 minus x. So its a unit is in kilonewton. Now at the end B, we will show the point load 0.8 kilonewton. And what is the distance in between point load and this section XX? So the total distance is 2 meters. So the distance is 2 minus x. Now we will apply the bending moment theorem. So how to calculate the bending moment at any section X? So for that we will first consider the sign convention. So when the moment is in clockwise direction, we will use the negative sign, and when it is in anti-clockwise direction, we will use positive sign. So if I move the compass in the direction of this load about the XX, then it is in clockwise direction. So we will take negative sign. So what is the moment? So this load multiplied by the distance in between this XX and this load. So this is the center point. So how to take this distance? So it is, so I will show here this distance is, so we have to multiply with this distance, and this distance is 1.25 minus x divided by 2. Now we will calculate this. So I will take this load, that is 2 into 1.25 minus x, and because of this clockwise direction we will take the negative sign. So mx is equal to minus 2 1.25 minus x multiplied by 1.25 minus x by 2. So this 1.25 minus x and 1.25 minus x will become square divided by 2. Now we will move to the next load. Now how to take the moment about XX? So if I move the compass, then it is in the clockwise direction. So again minus sign. So minus 0.8 multiplied by distance in between XX and this end B. So it is 2 minus x. So inside the bracket 2 minus x. Now we know that bending moment at any section. So mx is equal to EI d square y by dx square. So I will equate these two equations because these two equations are same. So I will equate the right hand side. Therefore EI d square y by dx square is equal to, now this 2 is getting cancelled, so minus 1.25 minus x square minus, now here I will multiply inside the bracket, so minus 0.8 into 2, that is minus 1.6, and this minus minus will become plus, so plus 0.8x. So this is the equation. Now we have to take the integration on both sides to get the slope equation, but the question is we have to calculate the deflection at the end B. So again we will take the integration on both sides. I will take here EI dy by dx is equal to, so I will take minus sign as it is. Now how to take this integration? So this integration is 2 inside the bracket 1.25 minus x, and because of this minus x we will write its a coordinate is negative, so I will multiply here with minus 1, and then next is minus 1.6 into x, and then 0.8 plus 0.8 x square by 2. We have to find out the deflection at the free end by using double integration method. So we will first take the integration for this equation to get the slope equation. So integration on both sides we will get EI dy by dx is equal to, now how to take the integration of this bracket? I will take minus sign as it is, so here 1.25 minus x bracket square, so it will become 1.25 minus x bracket cube by 3, and because of this minus x we will multiply with coordinate of x, that is minus 1, then minus 1.6x, and here plus 0.8 x square by 2. Now what is the rule to calculate the integration of x? So it is integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So here x is equal to 1, so it will become x square by 2, and then for this bracket we will take here instead of 2 we will take 1.25 minus x bracket cube by 3. We will take the constant of integration, that is plus C1. Now how to find out the value of C1? For that we will apply the boundary conditions. If we observe at this end A, x is equal to 0 and slope at the fixed end is also equal to 0. In this equation dy by dx is known as slope. So when we take x is equal to 0, then dy by dx is also equal to 0, and these are the boundary conditions, and when we apply these boundary conditions then we will get C1 is equal to 0. So when we put C1 is equal to 0 then we will get the slope equation. So what is the final slope equation? So I will write here, therefore EI dy by dx is equal to, so we have to simplify this, so minus minus will become plus 1.25 minus x bracket cube by 3 minus 1.6x plus 0.8 by 2, that is 0.4 x square. So this is the slope equation. Now we have to find out the deflection, so we will integrate this equation to find out the deflection equation. Now we will take the integration on both sides of this slope equation. So we will get EI y is equal to, now this 1 by 3 will remain constant. So how to take the integration? That is 1.25 minus x bracket raised to 4 divided by 4 multiplied by coordinate of x, that is minus 1. Then here minus 1.6 as it is, instead of x we will write x square by 2. Plus 0.4 as it is, instead of x square we will write x cube by 3 plus constant of integration C2. So this is the equation. Now we will simplify this. Therefore EI y is equal to, so we will write here 1.25 minus x raised to 4 divided by 12. So here is the minus sign because we have to multiply here with minus 1. So minus now 1.6 by 2, that is 0.8 x square. Then here plus 0.4 by 3 x cube plus C2. Now how to find out the value of C2? So we will apply the boundary condition. So we know that at fixed NA, x is equal to 0, slope is also equal to 0 and deflection is equal to 0. So in this equation, this y is known as deflection. So x is equal to 0. So when we put x is equal to 0, then y is also equal to 0. So these are the boundary conditions. And when we put these values in this equation, then C2 is equal to 0. So how to get the final deflection equation? Therefore, final equation is EIY is equal to minus 1.25 minus x raised to 4 by 12 minus 0.8 x square plus 0.4 by 3 x cube. So this is known as deflection equation. And for this deflection equation, we have to find out deflection at the end B. That is deflection at the free end. Now if we observe the diagram, for this point B, what is the value of x? So x starts from the fixed end towards the free end. So x is equal to 2. So to find out deflection at B, that is deflection at B, that is at x is equal to 2. So we have to put the value of x is equal to 2. Now if we observe all these calculations, here load we have considered in kilonewton, but standard unit is Newton. So we have to multiply this calculation on the right hand side with 10 raised to 3. So I will put the value. So deflection at B is known as YB. So therefore I will write EIYB is equal to, now here minus inside the bracket 1.25 minus 2 bracket raised to 4 divided by 12 minus 0.8 into 2 square plus 0.4 by 3 into 2 cube bracket complete into 10 raised to 3. And we have to divide latter with value of E and I, which is mentioned in the question. When we put value of E and I and we will transfer this to the right hand side, then value of E is given 10 giganewton per meter square. So standard unit is Newton per meter square. So we will write 10 into 10 raised to 9, and value of moment of inertia I is given 66.6 into 10 raised to minus 6. And if we solve this right hand side, that is numerator, then we will get this equation. So final answer is given YB, that is the deflection at point B is minus 3.25 into 10 raised to minus 3 meter. Now if we show this deflection YB, then it is in the downward direction, and that's why there is the negative sign. So we have to show this deflection. So this deflection will be in this way, and this deflection at B, that is this vertical distance from B to B dash, is known as YB.